See, Samir and अविनाश, स्टैड प्रो आपका हुआ है ना या नहीं?
नहीं सर, नहीं हुआ अभी तो हम
नहीं
लोग को
हुआ
स्टार्ट
सर।
ही नहीं हुआ सर।
Okay, okay. I thought it has been done. Okay. So today we are going to start with the Staad Pro software training, basic part. In this month, we are going to learn the steel structures. But before that, we will start with the Staad Pro first, basic part. So I think who knows Staad Pro software? Anybody knows? Or all are new for Staad Pro?
I know sir, but I'm not working in the Staad Pro sir.
Okay, okay. बाकी लोग?
न्यू है सर।
New, I guess. Okay, fine. Okay, so to start with, before Staad Pro, let's discuss about the modeling part first. So anybody knows why Staad Pro is used? What is the use of Staad Pro?
For
Yes,
analysis and designing sir.
for analysis and design. Okay. So Staad Pro is used for analysis and design. So what is meant by analysis?
Input the sir, input the load.
Mm-hmm.
So to determine the
Find
load
out
calculation.
movements and forces.
So yeah, so we give the input as a load and we get output as a maybe bending moments, shear forces. That means shear force, axial force, or deflections, or what else? Okay, these are the outputs in terms of forces, we can say. So input is also force, but it is a loads in terms of force, and output is also kind of force in terms of bending moment, shear forces, axial forces, like this. And design is, let's discuss about the analysis. So generally softwares are mainly used for the analysis. As far as STAD and ETAB is concerned, we generally consider them for analysis as a major part. And design means, what is design?
Column beam.
Yes, so design means deciding the sizes of the members, deciding sizes of members such that the stresses coming, actual stresses coming in the member should be less than permissible stresses given in the code. So this is nothing but design in code, IS code, or whatever codes you are using. And second is actual deflection which are coming in the member. So stresses are coming in the member, please keep in mind. Members like column, beam, slabs, like this. So actual deflection less than permissible deflection. So this is nothing but a design. See, try to understand in a simplified manner. Don't complicate the things in the beginning actually. Then you can go in detail of each part as per the codes and books. Okay. So this is design. Now today we will start with the analysis part in Staad Pro. Now let's discuss in detail the analysis again, just for so for example, see, we all of you know that can we do analyze real structure? Yes or no? Can we analyze real structures? Real structures means on ground, which we are constructing. Can we analyze
No
this?
sir.
Yes. So practically difficult, or I would say impossible for the time being. So it is not possible, and it will be very costly and may not be a good solution to things. So that's why what we do, we analyze the models. We don't analyze real structures, we analyze the models. And that's why the softwares are playing a bigger role actually. Okay, any software plays a bigger role because we can analyze the models. Now, what is model? So model is what? Modeling of any structure, what do you understand by that?
So mathematical representation.
Yes, it's a mathematical representation. For example, let's say you are considering this frame. Now assume this as a real structure. So you might have seen such kind of structure at entrance gate. In buildings, there is an entrance gate, there is a security cable, and such kind of structures are there. So assume that that is the real structure on ground. Now I want to show it on the paper actually, even though it is not real, but okay, let's assume this is a real because it is having 3D dimensions also on the other side like this, right? So let's say this is your real structure. Then this is also real structure. Now this real structure is having what? Real structure is having dimensions like this. So this is having this width. Let's say this width, let me assume this as a 600 mm. Then this depth, it is having depth also. Let's say it is also say 700 mm. Then this other dimension also like this in plan. Let's assume this as a 400. Assume, and then this height, let's say 4 meters. That means 4000 mm. Okay, all dimensions are in mm, and now it is resting on the ground. See, there is a footing also below that, below the ground. Let's say this is a ground level, and then there is a footing here. So let's say I don't want to show that here for time being, just let it be imagined. Okay, so there is a footing here, and this is your real structure having 3 dimensions. Now, and let's assume that we are having one wall over that. Let's say decorating wall is there above this. Decoration wall is there. Just for architectural purpose, architect has given some, and this wall is solid wall, let's say, of brick wall, and they will plaster it and they will have some elevation. And the height of this wall, assume it as a, let's say, say 1.5 meters. Okay, so this is the wall. Now this is your real structure, and then they will plaster it, paint it, and then it will look good. So this real structure, as far as structural engineering is concerned, structure is having loads, and due to load there will be stresses, and to resist the stresses we are going to put the material into that. It may be concrete, steel, or whatever. And to control the deflection, we will decide the sizes of the members like beams and columns. So we are more concerned with the loads coming on the structure and its geometry also. Don't forget. So it has a geometry. Now you can see it is a vertical. The cross section of the column and beam is rectangular, right? So and it has a C shape, geometrical shape. Let's say assume this. Now I have not shown the span also. So span समझो ये है वो 5 meters. Okay, 5000 mm. Now this real structure we cannot analyze, so we can prepare the model. So what we prepare? We prepare the model of. So modeling consists of geometry. So modeling में geometry है. Then modeling is having, we model the loads also. So we model the geometry. In that geometry we model the members. Members means column beams. So we are modeling geometry, then we are modeling loads. It may be dead load, lie load, or earthquake loads. And we are also modeling the supports, or we can say joints, supports or joints. So these are the 3 important things which we model actually, corresponding to the real structures. And this model is nothing but already discussed mathematical model. Why we call it as a mathematical model? Because we are doing it on the paper and doing the mathematical calculations using mathematical formula and all these things. Okay, now this real structure we can convert into the model, but there are definitely limitations we cannot exactly replicate the real structure in modeling. So there are certain assumptions whenever we model. So if this is a real structure, then modeling will not be exactly this, but it will be a mathematical representation of the real structures, we can say. So how can we model this? So in software doesn't understand 3D in general, I'm saying. So there are some softwares which also model the 3D structures, but Staad Pro ETAP is not modeling 3D structures. So if it is a column, then column is a 3D structure. We know this is 600, this is 400 plan and height. We can model the columns as a line element. So this is first criteria. Generally this line floor to floor height, so it will be something here. Now what dimension should be taken? Then this is a span of, let's say, 5 meters. So beam also can be modeled as a line element, column as a line element. So this is your geometry of the structure. Now you will ask, this is only a line, it is not having any depth and width. So this depth and width, we apply depth and width of the beam, apply in the software. Okay. As far as analysis is concerned, it is only concerned about the line element only. Now how we draw the lines, all of you know that. If you want to draw a line, what is required? क्या चाहिए?
Height चाहिए sir.
Yes, so see, line के लिए 2 points चाहिए. So whenever you want to draw any line, it requires 2 points. So these points, we call it as a nodes in softwares. Okay, nodes or points. Then and then you can draw this line beam. Then again, if to draw the column, you want this point and this point. And then you can draw the column. So drawing it, you can draw from number 1 to 2. So this will be your direction of drawing from left to right, let's say. And from column, let's say this is your 4 and let's say 5. So this point from 4 to 1, you can draw the column like this. And 5 to 2, you can draw the columns. So we are requiring these 4 points first. So in geometry, we require the points first, then draw lines. Okay. And then you can assign the sizes to the lines. So for beam, it is 400 by 700. So this beam is having 400 by 700 size. This column is having 400 by 600 size. Now there is a wall. So due to wall, what will happen? Do you model any brick walls in the softwares or even on paper also? Do we model?
No sir.
So we model due to brick wall, what will happen to this structure? The brick wall will have a load. That means self weight of the bricks, isn't it? This wall. So what we will do, we will apply the load of the brick wall here. Correct?
Yes
So
sir.
this real brick structure or brick wall, we are converting in terms of load here. So this will be load kilonewton per meter for the bricks, let's say. Then definitely there will be self weight of beams and columns here also. So you can add self weight of beam here and self weight of column here. Okay. Generally, self weight of the model is done by the softwares generally. Whenever we do manual calculations, we actually calculate it. Now, if you see this frame, and if you are, these are the footings below this ground, right? Now, at this point, generally we provide plinth beams for tie. So there will be plinth beam here, right? Okay. So we have a choice to model the plinth beams or not. That is our choice. But let's say I want to model this till this point only. So generally frames, you can assume the supports as fixed supports or pinned supports, provided it is a stable structure. So all of you know the fixed and what is pinned structure we discussed last time. So assume this base as a fixed support. Okay. So there will be bending moment diagrams and so on. So fixed support you can give the fixed condition or fixed support here at the joint 4 and 5. Okay. So this is your fixed support. Now what I have modeled, I have modeled the supports, I have modeled the members and their geometry. Members means their sizes, and geometry means height of the column and span of the beam. So this height is 4 meters. Let me put in 4000 mm, and this span is 5000 mm. Okay. So already I discussed what is meant by model is putting the loads, putting the sizes, and putting the geometry. This is the. Now once you analyze this, so for analysis, if you do it manually, what kind of methods we use for the analysis of structure? क्या क्या यूज करते हैं हम एनालिसिस के लिए? हमने किया है ऑलरेडी कॉलेज में. हेलो.
MDM and slope deflection.
Yes, yes. So there are certain methods actually for analysis. Manual analysis. We have moment distribution method, or slope deflection method, or stiffness matrix method, Kani's method. There are some other methods actually, Kani's method and so on. Okay. I'm not going to, these are used for indeterminate structures. So I hope all of you know that what is meant by indeterminate. So if the reactions are more than 3, then it is called as indeterminate structures. Generally, these kind of frames, when the members are more, it is indeterminate in general. Okay. Now, if you want to calculate the weight of the brick wall, you know how to calculate. So, okay, let's first see. So, have you understood how to model and what is the meaning of model and why to model? And so, this is your real structure. This is your mathematical model. So, I will call this as a mathematical model. Now, mathematical model we can do on the paper also, and we can analyze manually, or we can do the in the softwares, and we can analyze in the softwares. So generally these calculations, whatever we do using moment distribution and slope deflection or whatever method you are using, these calculations are very much complicated and time consuming. See if you and time consuming, and that's why we are using softwares. So software is doing only this point. So what is the benefit of software? Can anybody tell me software का benefit क्या है हमें? क्यों करते हैं हम software use क्यों करते हैं? Manually भी कर सकते हैं ना?
सर टाइम सेविंग है.
टाइम बहुत जाता है सॉफ्टवेयर ये मैनुअल करने में, पहली बात. देन एक्यूरेसी लेवल इज लेस. Accuracy is less because see we cannot do complicated mathematical calculations quickly. So we have to assume certain things. We then do the approximate methods, and then we do the final analysis. But in softwares, it can do complicated methods because the softwares are based on finite element methods, FEM, finite element methods. And it can do such kind of stiffness matrix calculations of any size. Stiffness matrix calculations. All of you know stiffness matrix. So it can do of any size because you know that we can, as a manual calculations, we can solve the matrix of 3 by 3 only. So let's say this is X, Y, Z, X1, Y1. So you don't go in detail, but just. So this is a 3 matrix, you know, we have used in maths, M2, M3 something. These matrix calculations. Now we, as a manual method, we can go for 3 by 3. But if I ask you to do 6 by 6 matrix, then definitely it is very difficult. And we cannot do this. So we need to assume certain things, or we just forget this matrix and do something else. So that is the way, and that's why we want softwares to do such kind of longer dimensions. Now let's take simple example, one more simple example. So समझो एक बीम है, लेट मी मॉडल दिस रियल स्ट्रक्चर पहले दिखाता हूँ. जैसे एक बीम है, which is resting on a block. Wooden block है, wooden beam है, whatever, or RCC beam, let's say. ऐसे block है. Now this beam, this is very simple beam. I am assuming this as a simple beam. And let's say again there is a wall here, like previously. So this is a wall. Wall height now in this case assume 1 meter. And then width of the beam assume this as a 0.3 meters. Now I'm assuming this in meters. The span of the beam, center to center span I'm drawing. Center to center of this is 4 meters. And beam depth is, let's say, 0.3 meters. Okay. Or 0.2 meters. I'm just assuming for trap. And this is a brick wall. Now, how to model this? Yes. Generally, this dimension we don't model actually, even vertical also for beams. So what is required? So beam we can represent in terms of a line. And for line, what we want? Already discussed kiya humne. For line, we want 2 points. So this is first point. Generally, we draw it at the center of the supports. Then this is your second point. And then you will draw a line. So this line is nothing but your beam. Now, what kind of supporting conditions you can assume? If you assume this as a simply supported, because it is only resting on the blocks. Let's say these are wooden blocks. So you can say it is a hinge or pinned connection, correct? Now there is a wall, so there will be load of the wall, which you can model, and load of the beam also, self-weight of beams. So this we know, we have already done this in engineering. And this is your 4 meter span. Now this is your mathematical model, this is your real model. Now if you want to draw the calculation of this load, so let's say brick wall height is 1 meter. So brick wall weight कितना आएगा? Brick wall dead load कितना आएगा? 0.3 meter brick width. Then height. Height 1 meter. And density.
20.4.
Assume for 20 kilonewton per meter
Okay.
cube. For just आसान हो जाएगा. 6 kilonewton per meter is the weight of brick wall. Now beam का कितना आएगा? Beam का dead load. Self weight 0.3 into 0.2 into 25. कितना आएगा ये? 1.5 kilonewton. Right. So what will be this W then? W value कितना आएगा दोनों का मिला के? 7.5.
Yes, sir.
Now you have prepared the geometry, you have given the supports, you have given the loads. Now how to analyze this manually? Tell me. कैसे करेंगे? Analysis simply supported beam का.
So पहले वो forces reaction निकालने support reaction.
So ये reaction कितना आएगा मेरा? एक काम करते हैं, for time being I am assuming this 7.5 as a 8 kilonewton per meter for calculation के लिए आसान होने के लिए. That's it. बाकी कुछ नहीं, it should be 7.5. So कितना आएगा? 8 रहेगा तो ये 16 kilonewton. Yeah. And then bending moment निकालना पड़ेगा इसका. So bending moment at the support कितना आएगा? Support पे hinge है ना, hinge support है ना, कितना आएगा?
Zero.
जीरो आएगा
Zero
एंड देन
आएगा।
इट विल बी पैराबोलिक रहेगा, सेंटर पे ज्यादा रहेगा, सेंटर पे वैल्यू कितना आएगा? सो यू कैन रेफर, आई थिंक बेसिक्स हुआ है आपका, जिनका हुआ नहीं वो वीडियो रेफर करो मेरे. So either you can calculate the reactions and by first principle you can calculate the bending moments, or you can use formula like WL square by 8. So M is equal to WL square by 8. It depends on you. ये simple है इसलिए हाथ से कर सकते हैं. 4 square upon 8. So it will be 16 kilonewton meter and shear force कितना आएगा? WL by 2. So it will be 16 kilonewton. Correct. So this is your calculation. And this is your analysis. Now this is very simple beam, so we can analyze this, but as we have seen this problem, it is difficult to do it manually. Yes, still there are possibilities by using approximate methods, but not accurate methods. I think in manual say our training, we have already discussed that we can assume point of contraflexures and then we can do the approximate analysis of frames, but they are approximate, they are not accurate. The accurate modeling will be done by softwares only. Okay, but the approximate methods will help you to judge the results, whether they are within the limits or what, within acceptable limits as per our expectations. Now let's start today with the Staad Pro software. Now in this Staad Pro, we will model this beam, simple beam first, then we will model the frame and we will see the results. So you can click on the Staad Pro like this in your computer laptops. You can click on the shortcut, then you will see this screen first. Okay, so in the beginning, what you need to do, click on the file, click on the configure, and here actually they are asking for which units you want. There is an English unit and metric unit. So as we are using meters kilonewton system, SI system we can say, so it is a metric. English means pounds for loads and inches and feet for dimensions. Okay, so these Americans are using English, we will use metric. So metric, and then apply, accept. Okay, so we have configured the units first. This is very important, otherwise the problem, there will be problem. So if you are starting the Staad Pro, then please configure this first. Generally you need to configure it once only, but okay. So this is your first part. Now we will start with the new project. You can click on the new project here by clicking new project, or click on the file and new. Now there is a space, plane, floor, something is given. See, don't go in detail in every part in the beginning. पहले ज़्यादा मत सोचो इस पे. The only thing whatever I am discussing with you, please focus on that. So you can click on the, let's say, plane. अभी plane ही है ना, हमारा 3D model तो नहीं है. ये
नहीं
plane
है.
है ना. So we will model that simply supported beam first. So let's assume plane, and let me call this as a simply supported beam. Give the name to the file. This is a file name. Now you can save this in your folder, whatever you choose. Click, select the folder from your computer, and then now here please check whether it is meter and kilonewton. So this is as per our expectations, meter, kilonewton. Then go to the next and let it be. Just click on the finish. Here it is, add beam is checked. Okay. Now this is your first graphical interface of the Staad Pro softwares. There are a lot of things. Whatever I am going to teach you, focus on that first. Gradually we will learn additional commands. So today our aim is to model this simply supported beam, whatever I discussed with you. So the minimum commands which are required for that we will discuss. Now here you can see snap, node beam, default grid. Just close this. Okay, close this. Now what is required for modeling? Geometry. Geometry के लिए क्या चाहिए? Now we already discussed to draw a beam like this. This is your real structure. You want 2 points, correct?
Yes, sir.
So any point you can define in space. By how you can define the point in space? ये point को कैसे define करेंगे space में?
XYZ coordinate देखे.
So we require coordinates of the points, correct? So अभी इसको मैं, this point we can call it as a node in Staad Pro language. So this point is a node, and any point in space can be defined using coordinates x, y, and z. Now here, now we'll go into the Staad Pro software. Can you see here coordinate x, y, and z is written over here, isn't it? X, Y, Z दिख रहा है ना?
Yes, sir.
Yeah.
Node 1 पर.
And here the x, y, z is given where you can put the coordinates for that node. So here node 1 is here, x, y, z is here. Now here in 3D you can see this. That means if you now see, I'm just drawing it by pen. This पहले बताता हूँ मैं कैसे. So ये in x direction, let's draw the beam in x direction. So मेरा beam ऐसे रहेगा. This will be my beam, right? ऐसे कुछ तो आएगा. Can you see this x here? So I want to
Yes.
draw the beam in x direction, and then I will put the support here like this. ऐसे मेरा expectation, and then I will put the loads. These are my expectation to model in the software. That means I want these 2 points. Okay. So ये पहला point है, समझो इसको point number 1 बोलता हूँ, node number 1, and this is my node number 2. अभी node number 1 का x, y, z coordinate क्या है बताओ? ये मेरा x है, ये मेरा y है, और ये मेरा z है. बताओ. What is the coordinates of node number 1? दिखा है, देखो. So generally first node you can assume at a 0, 0. मतलब यहाँ ही assume करो. समझ में है? Origin पे.
0, 0, 0.
So assume 0, 0, 0 is your first node. क्योंकि कहाँ तो start करते, that is nothing but 0. We start at 0 in any coordinate systems. Now 2 का बताओ फिर coordinate क्या है? ये हमारा span of the beam कितना है ये? Now tell me what is this coordinates? X, Y, Z.
400.
400.
हाँ, तो यही लाइन पे आएगा क्योंकि so 4 0 y because यही ये लाइन पे x लाइन पे और 0. समझ में आए सभी को?
Yes, sir.
0 0 0 4 0 0. Have you understood the coordinate system also? ये यही इसको मैं यहाँ निकाला मैंने. So whenever you put any nodes or draw anything, just look at this. Now let me go in this. Now let me delete this. अभी first node का coordinate है 0 0 0 0 0 and 0. Second coordinate का कितना था? 4 0 0. Now you can see in this on the screen. ये दिख रहे हैं 2 points.
Yes, sir.
Yeah. Now as we are not having any z coordinate here because our structure is not 3D. So you can only see the XY plane. Now you can see 3D plane here in the white screen. If you want to see only front view, X and Y coordinate, you can click here, yellow color, view from plus Z. Now here you can see Z is perpendicular to the screen and X is to the right side, Y is to upward. Can you see this? I have only seen, I'm seeing only the front view by clicking here on the yellow. You can see in this 3D cube, yellow is front view plus Z, view from plus Z. क्योंकि ये 2D मॉडल है इसलिए मैं यही प्लेन में काम कर रहा हूँ. दिस इज माय प्लेन नाउ. दिस इज माय XY प्लेन. हियर यू कैन सी ये X, ये Y है और ये X है. करेक्ट. Now see if you click over here, whenever I say click, it is a left click. Okay, mouse, left mouse click. You can see it is coming getting highlighted by dark blue. And if I click over here, then it is getting highlighted by dark blue. That means this screen is becoming active. Whatever you click, that will become active. If you click over here, this window is becoming active. If you click over here, it is becoming active. Now, what is the next step? I want to draw a beam from this point to this point. So this is my node number 1, this is my node number 2. So you can right click here, click on the add beam. Now you can see the cursor got changed. I say there is some plus sign and that small beam is there. Let me escape this. Click on the escape from the keyboard. Now you can see this arrow is called as the cursor, and this is a beam cursor. Can you see? If you go over here, this arrow is beam cursor. You can see there is a node cursor. There are two node cursors. For the time being, let's discuss on this arrow. This is a node beam cursor, and if you right click means on the mouse, right click and add beam. Now this is add beam cursor. Can you see?
Yes, sir.
Now go to this first node, click. Whenever I say click, it is always left click, and then again click, left click over here. Now you have drawn the beam. Now this beam, add beam cursor is there. Let's get out of this cursor, escape button from the keyboard. Now again it is a normal cursor, beam cursor. Okay. So we have drawn the beam. Now what is the next step?
Support.
Support. Okay. Now generally I recommend all of you, whatever mouse you are using, it should be scroll mouse, because for using software, scroll mouse is important. Now if you do the scroll here like this, you can zoom in, zoom out, okay, using scroll from the mouse. So as per your, say, requirements. Now we have created the nodes using coordinate axis x, y, z. So first node was the 0, 0, second was 4, 0, 0. Second, I have added one beam from this point to this point. Now what to do? Now can you see here some commands are there? Click on the general. Okay. ये कुछ नहीं है. Once you click on the general, you can see here the properties whole structures. Okay. So, and here you can see, click on the properties here. Now this dialog box is there. Now, first of all, we will give the sizes to these beams. So now in Staad Pro, there is a system. I think जिसका ETAB हुआ है उनको पता रहेगा. Whenever we do anything modeling, first we define something. पहले हमें define करना पड़ता है.
Yes, sir.
बाद में हमें either draw करना पड़ता है या assign करना पड़ता है. So पहले define करना है, बाद में assign करना है. Define, assign. Assign to selected मतलब जो select करोगे उसको. Abhi, now I see this line is not having any dimensions or sizes of the beam. So this line is a beam and beam is having a size. So हमारा beam का size अभी क्या है? कितना था वो? 200 by 300. अभी ये मतलब 200 नहीं, width कितना था उसका? 300 ना? And ये 200 है समझो. So this is your width, this is your depth. अभी उल्टा किया है क्या? नहीं तो नहीं, ये logical नहीं लग रहा. ठीक है. Let's assume this as a width 300 और depth 600. चलो assume करो. Correct. लेकिन हमारा मैनुअल कैलकुलेशन के लिए चेक करने के लिए डिफिकल्ट जाएगा. लेट इट बी, डजंट मैटर. बी है और डी मेरा 200 है. So I will define these sizes in the software first, and then I will assign this. So I will tell the software to assign this size to this beam. Okay. Now click on the properties, then click on the define over here. Now there are different shapes: circular, rectangular, T, and other. I know that my beam size is rectangular shape in cross section. Now there is a, for width of the beam there is a ZD, and for depth of the beam there is a YD. Okay, so there are different nomenclatures actually. So YD is our depth. हमारा depth कितना है अभी? मुझे थोड़ा सा ये हो रहा है, आपको कंफ्यूज होगा मुझे लग रहा है. Let's change the size. Otherwise वो क्या बहुत बार गलती हो सकती है. Let me assume $300 as a, yeah. So depth of beam, let's say assume 6.6. Okay, the calculation करेंगे फिर से. As Z is width 0.3, B by D. Then concrete material, then add, click close. Now you can see the defined properties of the beam are over here. Then now the second part is you have to assign this. So what to do? Select this beam. Then you can see here assign to selected beams. Click here and then click assign. Yes.
Yes.
Now यहाँ R1 आया है. So a reference 1, that is R1. That means this size is assigned to this. So I have defined the size and then assigned the size to this. Now second part is click on the supports. ये फिर से करने वाले हैं हम, don't bother. Click on the supports, then again support भी define करना पड़ेगा. So create the supports. Click on the create. Click on the pinned. Now हमारा support है hinge support है. So click on the pinned. Click on the add. Now click on the support here. Now you can see the hinge support is assigned here, defined over here, S2. Okay, S1 is by default no support. Now we have defined the hinge support here. Click on this. Now see where we want to assign the support at the point, that is nodes. So here click on this point. So this is a red. That means it is selected, and then assign to selected nodes. Assign. Yes. Now you can see the hinge support is assigned to this point. Now I want hinge support here also. So click on this support. Click on this point, that is node. Assign to selected node. Assign. So we have assigned the supports, pin supports to these points, 2 points. What is the next step? Loads.
Assign loads.
So again here define load and assign loads. So click on the loads and definitions. Now here you need to click on the load case details, then add. Now this dialog box is created. I have clicked on this load case details and add. Then you see this dialog box or window. Now here let me call this as a dead load. Let me assume DL. Okay, I'm just giving the load case name to this. DL or dead load, you can name whatever you want. And then click add. Close. Now the load case is defined. See, we have not yet decided assigned any loads here. So load case name is defined over here. Now click on the dead load and again click on the add. You will see this window, and in this window there are different load types: self-weight, nodal load, member load, this and all loads. So our load is UDL. Okay. So UDL is nothing but member load. So click on the member load. UDL on the beam is member load, and which is uniform. UDL means uniform force. So click on the uniform force. Now here you can see W1 is there. This is load. You can see here representation. So if you want to draw such kind of loading on the beams, then you can use this command. Now what is our W1? कितना है हमारा 8 kilonewton per meter. Okay, right? Now here we cannot write 8 kilonewton per meter, but we generally write -8. So there is a reason for that. So if you see here, our coordinate axis is like this. ये हमारा y upper है और ये मेरा x है. And you know that our beam is drawn like this. Correct? ये हमारा beam है ना. और what is the direction of loading? Downward. So my W 8 kilonewton per meter is downward, and your y-axis is upward. And here you can see it is written as GY. That means load is downward and axis is upward. That's why I am putting -8 over here. Okay, please keep in mind whenever you put any gravity loads, either it is dead load or live loads, if generally they are in the downward directions, that means opposite to y direction here. So that's why -8. So okay, -8, put here -8 value and then add. Now there is a question mark over here, red color. That means this load is not yet assigned to this beam. So click on this load, select this beam and click on the assign to selected beams and then click on the assign. Then say yes. Now this load is assigned to the beam. Now we have defined the geometry, we have defined the supports and loads also all. So हुआ ना सब? I think sizes भी
सर
दिए
ये
उसको.
एक बार मेंबर लोड रिपीट करोगे?
करता हूँ. पहले से करूँ स्टार्ट से? ठीक है, स्टार्ट से करता हूँ मैं.
सर डेड लोड के बाद से.
बाद से इतना यहाँ से क्या? नहीं पहले से बताता हूँ, चलो सभी को कुछ डाउट्स रहेंगे तो. ओके, सो इफ यू वांट टू create the load, first you need to create the load case. So click on the load case, then click on the add and give the name of the load case whatever you want. So let's say dead load is my case, and click add and close. So dead load case is defined. Now click on the dead load, add, and our load is UDL on the beam, therefore it is member load. Click on the member load, then click on the uniform force because it is UDL means uniform force, and my UDL is 8 kilonewton per meter, but it is downward, so it is -8. Okay, why -8? Because my y-axis is upward and my load is downward, that's why it is -8 with respect to GY axis. GY means global y-axis. See, we are going to learn in detail slowly, but just keep in mind because we are learning the command also and technical also together. Click add, then click close. Now if you see the question mark, that means this load is not yet assigned to anybody. So click on this load, click on this beam and click on assign to selected beams. That means we are telling him assign to selected beams, then assign. So this is your load. So we have done the modeling part. Now analysis karna hai iska, calculations. So how to do? Click on the commands over here. Only remember this, whatever commands are there regarding the softwares, it is a tool you need to remember by practice. There is nothing much engineering aspect in that. Engineering is requiring the thinking for that. Okay, so commands, analysis, perform analysis. So we are telling him to perform the analysis and click OK. So this is first part. Then again we need to tell him click on the analyze and run analysis. So there are two commands. First is the commands analysis and perform analysis. Second is go to the analyze here and run analysis and then save. Now there are calculation of stiffness matrix which are done behind this screen in the analysis engine, we generally call it as the software programming, whatever they are doing. Now here you can click on the go to post processing mode. Now post processing mode means there are two modes. One is the modeling mode. Modeling में हमने जो किया था वो modeling mode था. अभी post processing मतलब we want to see the results in the post processing mode. So you can see all the results of bending moment shear forces in post processing mode. So click on go to post processing, click on the done. Now I want to select dead load case only. Click apply, okay. Now see, now the window, see this window got changed actually. So previously there were something general window tha na. Now there is a beam, node, displacement and all reactions. So these are nothing but the results which we are expecting. Now click on the beam. and click on the graph here. Now here on click on this beam. Now you can see here MZ. It is a bending moment diagram in red color. Then there is a shear force diagram FY. You can see this. All of you know that shear force diagram is here. And there is no axial force in the beams, you know. So this is your axial force, this is your shear force, this is your bending moment. Now if you click on this beam, then you get that. Now and this is your load. Now if you don't want to see this load, just here you can go here, loads, click here. Now the load is hidden actually. It is only hidden from the display. It is there, but it is hidden from the display. If you want to see it again, click on here, the loads here. So you can check, uncheck if you want to. Now I want to see the bending moment diagram on this screen. This is given here in the graph format, but I want to see here. So you can click here on MZ. Abhi dikh raha hai. Now if you want to see the shear force on this screen, you can click on the FY. Abhi FY MZ kya hai wo baad mein dekhenge hum. And again uncheck this. Now this is your shear force diagram. And here if you click over here 16 MZ को click करता हूं मैं. Is your maximum bending moment which is at the center. Minus 16 है क्योंकि bottom पे है और 0 at the supports. You can see 0 red color. So this 1 is nothing but your node number. This 2 is nothing but your node numbers. Okay. Then shear force also you can see shear force at node number 1 is 16. At node number 2 is 16. So ये हमारा आया था ना आंसर पहले. Bending moment कितना था हमारा?
6.
Yeah, 16 ही
16
था. Shear force is 16 है. Correct. तो वो that is justified here. So whatever manual calculations we have done, it is you can see in software also they are same. Yeah. So have you got the modeling part, basic modeling part? समझ में आए सभी को commands?
Yes, sir.
So अभी इसमें कुछ doubts है? कुछ समझ में नहीं? Any doubts regarding this? As of now?
सर जैसे आपने एनालाइज किया था स्ट्रक्चर, तो सर उसमें लास्ट में एक डायलॉग बॉक्स आया था तो उसमें 0 एरर दिखा था. जैसे अगर उसमें कोई एरर आता है तो उसको रेक्टिफाई कैसे करेंगे?
नहीं वो सी ये हम बाद में देखेंगे. ये बहुत ही आगे वाला पार्ट है ये. सो वी विल डिस्कस. अगर आपको एरर्स आएंगे ना तब उस टाइम में करेंगे हम. ओके.
ओके.
जब एरर्स आएंगे ना तब डिस्कस करेंगे. दिस इज ओनली बिगिनिंग. मतलब सॉफ्टवेयर का एरर आने का बात बाद में आएगा आपका प्रैक्टिस शुरू होने के बाद.
सर पहले प्रैक्टिस कर लूं उसके बाद ही कुछ बोलता हूं.
हाँ वो अभी तो नहीं. एरर इज वेरी मतलब थोड़ा एडवांस पार्ट है बोलेंगे मैं कि अभी ये आना चाहिए. जितना पता है उतना आना चाहिए और रन होना चाहिए. रन होने के लिए अगर डिफिकल्टी आ गया तो यू कैन डिस्कस विद अस किया गया मेरा मॉडल रन नहीं हो रहा, ये नहीं हो रहा, कुछ भी हो सकता है.
हाँ, वो
बट
सर
फॉलो
अभी
द स्टेप्स. हाँ फॉलो द स्टेप्स फर्स्ट एज इट इज जैसे मैंने बताया है.
ओके सर.
हाँ अभी और कुछ डाउट्स?
सर हमने जो लोडिंग केस डिफाइन किया था ना, वहां पर लोडिंग टाइप के लिए नो लोडिंग टाइप सिलेक्ट किया था क्या?
हाँ नहीं आई नो दैट. सो अभी मैंने सिर्फ ये रन करने के लिए दिया है. देयर आर सम मेनी थिंग्स वी आर गोइंग टू लर्न. अभी तक जो बताया वो सब सभी को पता चला है क्या? मतलब
सर एक बार
What's the
लोडिंग
idea?
केस आप बता दीजिए.
हाँ सर.
ओके लोडिंग केस फिर से बताओगे?
हाँ.
Now there is अभी ये रन हुआ है मेरा मॉडल. This is now if you want to go into the modeling, you can go into the modeling again. This is your post processing interface. यहाँ दिख रहा है ये post processing. If you want to go into the modeling, you can go click on the modeling here. Click on the modeling. तो अभी ये मेरा modeling का window है interface. You can click on the general. Then general में हमारा properties है, support है, loads and definitions है. Now you are interested in loads and definitions. So click on the loads. अभी यहाँ फिर से चाहिए आपको. Now we have already defined the loads over here. You can see the here plus sign. Click on the plus. Then dead load we have defined. Click on this plus. We have defined the load -8 here. Now you want to understand again this load, how to define this -8. ये चाहिए क्या? ये कैसे करना है करके? ओके फ्रेम का करेंगे. मैं फिर से बताता हूँ. We will go with the frame also. There also you will understand.
ओके सर.
Yeah, so we will learn some more. बताइए.
Sir, this self-weight and superimposed dead load together we are giving here.
Yeah, we are not asking software to do anything. मैंने सिर्फ external load -8 दिया है, that's it. Self weight तो included था ना हमारा उसमें. We have already calculated na beam and brick wall. So as I have already calculated manually, so I am not interested in us giving from the softwares. Okay, वो होने वाला है, मैं बताऊंगा आपको. See, there are very new people who are not knowing the software, so उनको फिर ये हो जाएगा, मतलब नहीं क्या. अभी क्या करेंगे, थोड़ा थोड़ा आगे जाएंगे डेवलप करते. We will go ahead.
Yes, sir.
Now we will model the frame. थोड़ा वही कमांड सीखने वाले हैं, बट थोड़ा सा अलग से. अभी ये W कितना है इसका, 1.5 मीटर का कितना आएगा W ये ब्रिक वॉल का. ब्रिक वॉल लोड कितना आएगा. Height is 1.5, width is 400. So 0.4 into height is 1.5 into density. कितना आएगा ये?
120.4 है सर, सॉरी. 12 sir.
So your brick wall weight is 12 kilonewton per meter. What else will be there? और कुछ लोड है क्या इस पे? सेल्फ वेट. बीम का और कॉलम का सेल्फ वेट भी है ना, राइट?
Yes, sir.
Now we will tell the software to calculate the self weight. So software can calculate the self weight. So जो मॉडल करेंगे ना आप सॉफ्टवेयर में, उसका सेल्फ वेट सॉफ्टवेयर निकाल सकते हैं. We will see how to do that. So
Sir,
we are, हाँ बोलो.
ई टैब में सेल्फ वेट हम लोग कैलकुलेट करके डालते थे. स्टैड प्रो के अंदर सेल्फ वेट ये खुद कैलकुलेट कर
नहीं,
लेगा.
टैब में भी नहीं दिया था कभी. कभी दिया था? We don't
तो वो
calculate.
SIDL दिया था अविनाश भाई.
हाँ,
हाँ, SIDL में डायरेक्टली करते थे ना.
हाँ हाँ.
हम हाथ से कुछ नहीं करते ना. सेल्फ वेट वी डोंट डू. स्लैब रहने अभी इसमें है ना, स्टैड में स्लैब का नहीं करते हम. स्लैब का कैलकुलेट करना पड़ता है सेल्फ वेट.
ओके.
बट वो आई विल टेल यू कैसे करते हैं. सो अभी सेल्फ वेट ऑफ बीम्स एंड कॉलम्स will be calculated by software. So I'm only interested in this brick wall. बाकी कुछ नहीं. Okay. बाकी सॉफ्टवेयर को बताएंगे. So go ahead again to the Staad Pro software. Click on the new project, file new, then plane. Now see here. क्या रहेगा इसका? Let's say frame, and select the folder where you want to save the files. Okay. And then click on the meter and kilonewton here, and then next. Then finish. Now again, this is your new. Now here, snap node beam, close this window. Now what we want for any modeling, first क्या रहता है हमारा पहला काम? Coordinates. So we should know what are the coordinates. अभी ये कितना coordinate है? Now let me do one thing. अभी यहाँ है ना, थोड़े now let me change the names of the coordinates. ये ना. Now let me assume this is my first coordinate. Okay. This is my second coordinate. This is my third and fourth. Okay. Now you can front view में कैसे रहता है हमारा XY coordinates. ये मेरा coordinate कौन सा है? ये वाला.
X.
ये वाला.
Y.
And Z is perpendicular to the screen, so I don't want to draw this. Okay. So अभी 1 का कितना आएगा coordinate? Let's say assume 1 as a 0 0 0 first part. Okay. Now tell me. मतलब again एक काम करता हूँ मैं. ये मेरा first है ना. So let me draw the coordinate there itself. वहाँ ही मैं निकलता हूँ. So this is my x, this is my y. So मेरा ये जो कोऑर्डिनेट है, ये पॉइंट कौन सा, 1 का ये पॉइंट, ये मेरा 1 पॉइंट है. So 1 पॉइंट का कितना आएगा कोऑर्डिनेट? 0
0 0.
हाँ, अभी ये, so because this is origin. Now tell me the coordinate of 2. We want in
040.
040. We want in meter, huh? Because Staad we put all the dimensions in meters. So 040, then 3 coordinate कितना है?
4 होगा सर.
4
0 0
4
4
0.
4 0.
और ये वाला 4 0, right? Correct है ना?
सर 500.
Sorry,
सर
sorry.
ऊपर वाला
5.
भी 540.
हाँ, ये ऐसे आएगा. 5 हमारा. So ये मेरा 5, ये मेरा 5. Okay. X है ना ये. So let me put these dimensions in meters. ये मीटर में लिखता हूँ मतलब. Now this is fine, and then we have the sizes of the beam is 400 by 700. Sizes of the column is 400 by 600, right? And
Okay.
supports are fixed one here. So this is enough for Staad modeling, correct? And yes, load also we have calculated here. Load कितना निकाला था हमने? 12. तो ये मेरा
Yes,
W is 12 kilonewton per meter. Plus बाकी सेल्फ वेट भी आएंगे ना उसमें.
yes sir.
तो वो सॉफ्टवेयर करेगा, वो बताएंगे बाद में. ओके, go into the Staad screen. So first one is the 0 0 0. Click 0 0 0. Now second coordinate, point number 2 कितना था हमारा?
4 0 0.
देखो पहले फिर से.
040.
040. Two coordinate 040. So it is 04. See, I am giving you this from the basic principles first. There are shortcuts of modeling, but वो बाद में देखेंगे हम. So second, third one is
540.
540. And this one is 500.
500.
Now you can see here, ये 4 coordinate nodes got generated over here. Now I want to see the front view only. So click on this yellow part as it is a plane frame. Now here X is right, Y is upward. 4 nodes are created. Now if you want to see the node numbers, so if I ask you what is this node number, क्या है ये node number इसका?
2.
2 है. But when the model is very big, it is very difficult to understand which node number is which. So what can you do? You can click on this node cursor, okay? Instead of beam cursor, click on the node cursor and take this cursor near to the node. I'm not clicking, I'm just taking this near to this, moving this. 2. If you go over here, 1, 3, okay? So this way you can see the node numbers. If you forget the numbers, let me go again into the beam cursor. Click on the beam cursor. Now what is the next step? Right click, add beams.
Add beam.
Now see, Staad doesn't understand whether it is a beam or column. Okay, so that's why this add beam is the command even for columns also. So click on the add beam. Then generally draw the members in the positive coordinate axis direction. Okay, so our positive y axis is upward. So from bottom to top, click on this, then click on this. So I want to draw the column from bottom to top. Again, this column from bottom to top, and this beam from left to right, because X is from left to right. So click here and click here. I hope all of you got this. Now this is in add beam cursor escape. फिर से बताता हूं मैं. If you want to delete this or undo command this, there is a command here, undo, or you can control Z from the keyboard, control Z. So there are 4 nodes. Right click, add beam. Now this cursor is changed. Click on this. Click means left click. Then here left click. Then click here. Click here. And from here to here. So this is your drawing command in the Staad Pro. Now escape. Then what is the next? Click on the general. So this was the geometrical part. Whatever we have done, it is a geometry. Now click on the general. Click on the properties. Means I want to give the sizes of the beams and columns. Now define. The shape is rectangular shape. Now what is the ZD is width and YD is depth.
Yes.
So YD depth. Depth of beam क्या है हमारा? क्या था?
360.
700 है मेरा beam का depth, right? So,
Yes, sir.
Or width 400 है. So go there. 700 means 0.7, 0.7. And width is 0.4. And add. यहाँ concrete है. Concrete का material है हमारा. Close. So this beam size is defined. Now you can define many sizes. Not necessarily only single size. There are some columns which are having different sizes. Some beams are different sizes. Now our column size is different than this. So click again on the define. Click on the rectangle. अभी यहाँ मैं column का देता हूँ. तो depth of column क्या है? 600 and width 400. So 600 will be my depth. That is YD 0.6. Click on the ZD is 0.4. Add.
Sir, 4.
0.4 ना? Cross section size है ना ये? These are the cross sectional sizes, members.
Okay.
B and D. Now what is the next step? Define के बाद assign रहते हैं, right? So this is first part is click on the first. This is my beam 0.7 by 0.4. Select this, select the beam because I want to assign this size to the beam. So click on the beam.
Assign.
And then click on the assign to selected beams and then click assign. Yes. So I have assigned this size to this beam. Now assign this size to the column. So click on this size. Click on one column first. Assign to selected beams. See beams से ये वहाँ column बिलम उसको समझ में नहीं आता कुछ. Assign. Yes. Then again click on this. Click on this column. Assign to selected beams. Assign. ये बीच-बीच में save का command ही करना पड़ता है. So we have assigned the sizes to the beams and columns. So we have defined multiple sizes now in this case. Correct. Next step.
Define the load.
नहीं support पहले करेंगे. So property के बाद support है यहाँ. If you go down, support. So click on the support. Then click on the create. Now fixed support है ना हमारे. So click on the fixed. Then click add. Now you can see the fixed support is generated here S2. The symbols are different for different supports. Fixed के लिए ऐसे है rectangular shape. So click on the support. Now you can see the cursor got changed. This is called as the node cursor. There is an arrow and small circle is there. So this is a node cursor. So I want to assign this support to the node. Which node? This node. Click on this node. You need to click on, just don't take it near to this. Click here. Now red is here, red node. Assign to selected node, assign. Yes. Now see, fixed support is generated. Now here also go near to this, click, assign to selected nodes. So fixed supports are assigned to the nodes. क्या next step क्या है? Loads. Now go to the loads. Define the load case. Click on the load case. Add. Now give the name here as dead load. अभी सभी dead load ही है तो चलेगा dead load. Add. Now click on the dead load. Then add. Abhi this time we will tell him to put the self weight also. Okay. So if you see here the self weight, click on the self weight. Then click on the self weight load. And here y direction. See, you know that gravity direction is y direction in our model. So click on the y. It is by default y, and then -1. Now -1, as I told you, because y-axis is upward and gravity loads are downward. So just put this -1 and then click add here and close. You can see self weight is generated over here, but there is a question mark. That means it is not yet assigned to this. So just click on this self weight and assign to view, because see, we want to assign the self weight to all the members in the view. So I want to assign all these beams, columns, whatever is there within the model, it will be assigned to total view. So click on the assign to view, assign. Abhi it will do it behind the screen calculations. Self weight कैसे निकालते हैं किसी भी member का? Anybody knows? Can anybody tell me how the software is calculating the self weight? बताओ कैसे कर रहा होगा?
Member size into density.
Yes, member size into density. That's it. Very simple. We have already given the member sizes, and the density we have decided given the concrete material also. So concrete material का density into size of the member, automatically self weight calculation करेगा software, right? Now, what load is pending? Any other load?
member
This-
load.
Yeah, wall load is pending, right? Which is 12 kilonewton per meter. So go there. Now click on the dead load, because dead load is a case. I want to add that load into this case. So first I have added the self weight. Now again I will add the wall load. So click on dead load and then click add. Now member load and uniform force. So this is minus 12. Add. Now there is a question mark. So I will assign this load. Click. Now where I want to assign? On the beam. Click this beam and say assign to selected beams. Yes, so wall load is assigned. Self weight is also assigned automatically here in the case. Next, क्या है बाकी? Next है, then go to the commands. Go to the commands, analysis, perform analysis. Then click OK. Then go to the analyze. Here, run analysis. Save. Okay. Now I want to see the results in post-processing mode. Go to post-processing mode, then click on the done. Then click apply and OK. Now click on the beam, graphs. ये zoom in, zoom out कर सकते हैं. Now, if you don't want to see the loads here, you can click on the loads here. Now, if you want to see the bending moment diagram for this, click here. Now, this is your bending moment diagram. So all of you know that it is a fixed end beam. इसलिए इस यहाँ moments आए हैं ना. If you want to see the bending moment diagram on this screen, click this MZ. अभी ये ज़्यादा convincing है. Correct. So all of you know this bending moment diagram of the frame with fixed support looks like this only, isn't it?
Yes, sir.
Now if you click over here, then you will see the results. अभी ये left side का जो moment है, ये है 23.2 और right side का भी 23.2 and center sagging moment is 34.9. If you click on the column, then you will see ये 11 है और 23.2 है. Now tell me, 11 moment, is it at the bottom or at the top. कहाँ है ये? One sec. कैसे? How you understood that?
So node की मदद से भी देख सकते हैं.
हाँ, तो ये 4 node कहाँ है? Can you see this 4 node? This is 4 node and this is 3 node, right? आपको पता चाहिए ना? Now here there is a choice. मैं बताता हूँ अभी यहाँ इसमें. So either I told you, you click here, node cursor पे click करो and then take this node near to this. Now this is 4 node, yes? मतलब ये 4 result 11 है bottom का है. If you take this cursor here, you will see third node, 3 node. 3 node मतलब 23.2, यहाँ 23.2 है. So अभी एक काम करेंगे और यहाँ नोड कौन सा है मेरा? ये फर्स्ट नोड है और ये सेकंड नोड है. So if I ask you to write down the results, moments के रिजल्ट राइट डाउन करने के लिए, तो इसका मतलब ये है कि ये मेरा है. लेट मी ड्रॉ, ये इस पे क्लिक करता हूँ. लेट मी क्लिक ऑन द बीम. 23.2. So this is my 23.2. This is my 23.2. Here you can see. Then this one is maximum here 34.9. ये minus because वो as per the sign conventions. Then ये कॉलम का कितना आएगा? ये है मेरा 23.2 and this is your 11. Again same ही आएगा, symmetric beam है इसलिए ये 11 रहेगा और 23. Can you see this 23.2 and 23.2? Why these two numbers are same? Anybody? कोई बता सकता है ऐसे क्यों है? कॉलम का मोमेंट भी सेम है और बीम का भी सेम है. Why it is so? Equilibrium, joint equilibrium, isn't it? For equilibrium, definitely whatever moment is generated in the beam, it will be transferred in the column as it is. So this is, we call it as a joint equilibrium and it is justified. If there is a difference in these two values, then we can say that there is some problem in the software or any modeling or whatever. It has to be matched in the plane frame. Then and then you can say that your software model is correct. So these are simple checkpoints to verify the results of the software. Okay, so you got this. Then if you click on the shear force Fy here you can see Fy. So click on the shear force Fy. Now let me uncheck this MZ. Now this is your shear force diagram for beam, and for column it is rectangular shape. So all of you know this, rectangular for columns and this triangular for beams. Now if you click here, then you can see the shear force values 46.5, 46.5. So this is my 46.5 for beams, and for columns, if you click on the column, then this is 69.1. Where? Sorry, yeah, shear force यहाँ है 8.54. So 8.54 is the shear force. यहाँ भी 8.54 है. Now, what is additional force which comes in the columns? Column में और क्या आता है? Apart from shear force. So there will be axial force, right? Downward. So that you can see in Fx. Here Fx. So if you click on the Fx, then you can see here 69.1 or 46.5. ये कहाँ है बताओ? Where is the 69.1? You know this is the node number 4. यहाँ दिख रहा है ना? और ये 3. 69.1 at the bottom and 46.5 at the top. Can you tell me why there is a difference in the axial force? क्यों आ रहा है ऐसे? ये टॉप में 46.5 है, यहाँ मेरा एक्शियल फोर्स है 46.5. Fx मतलब एक्शियल फोर्स, और यहाँ कितना है 69.1. Can anybody tell me why the axial force is different here? ये bottom में ज्यादा है और top में कम है, बताओ. 1 kilonewton में. Anybody from you? Tell me why the axial force is.
Self weight is added there.
Self weight is added, correct. So in this 46.5, only beam load is transferred here at this point. But after that, there is a self weight of column which is added. That's why it is coming more. Okay. So these are quite small things which you understand as a common sense. Okay. So see, today's first few sessions will be only mechanical sessions. We are not going in detail regarding the engineering aspects, but still I want to add that. Just do the modeling mechanically as a practice. Okay. The way I told you, as it is, don't look at the all other commands. There are a lot of commands here. You can see here this animation, graph, traces. If you go in the modeling, there is a general, there is a spec, this material, design, this, that. Don't look at those say tools or commands. We are going to learn everything ahead. Don't look each and every command. Just do the modeling as I told you. So as today is the first, yes, please.
आता बीमला आपण रिएक्शन दिली म्हणजे लोडिंग वगैरे
Mhm.
आणि त्यानंतर आपण बेंडिंग मोमेंट आणि एसएफडी चेक केली ना,
Mhm.
मग दिसताना सिम्पली सपोर्टेड बीम दिसतोय, मग ते मुवमेंट सपोर्ट जवळ कशी दाखवली?
कुठल्या बॅचचा आहे तू? आता नवीन बॅच का?
हो, नवीन बॅच.
एक काम कर, तू माझे ना ते बेसिकचे सेशन्स आहेत क्लासरूमला, नसतील तर मी सांगतो. त्या स्टडी कर. स्टील आय विल टेल यू कसं आहे ते. कारण हे बेसिक आपलं फिक्स एंड आहे ना. हा, दिस इज अ रिजिड जॉईंट.
ओके.
रिजिड जॉईंट म्हणजे फिक्स्ड होतो तो, सिम्पली सपोर्टेड नाही होत.
चालेल.
कळलं का? रिजिड जॉईंट म्हणजे हे माझं ॲझम्पशन आहे ना, रिजिड आहे म्हणून. जनरली फ्रेम आपण रिजिड ॲझ्युम करतो. जर मी हे सिम्पली सपोर्टेड म्हटलं तर मग येईल ते.
Okay.
See, by default, I will tell you. He's asking the question that why there is a bending moment here in the beam at the support. Okay.
Yes.
See, as there is a bending moment at the support, that means this joint is fixed joint or rigid joint. Okay. Now we can control the supporting conditions if you want. If I want this to be simply supported beam, then I can do it. I can tell the software, please make this as a simply supported. I will tell you how to make that. But by default, generally we do the rigid joint or fixed joints in the structures, especially in buildings. Okay. म्हणजे जे beams, आता सांगतो मी तो आहे पॉइंट, तर थंब रूल म्हणून सांगतो मी. The beams supported on the column shall be considered as fixed beams, and the beams which are supported on the beams should be considered as simply supported beams. समजलं काय?
ओके.
हा बीम कॉलम वरती आहे म्हणून हा फिक्सच घ्यायचा, त्याला नाही सांगायचं सिंपल करायला. जर हा बीम वर रेस्ट असताना तर मग सिंपल करायचं त्याला. गेटिंग? हा थंब रूल आहे, हा प्रॅक्टिकल त्याचे इम्प्लिकेशन्स आहेत, मी सांगतो त्याचे काय हे रिझन्स आहेत, पुढे सांगतोय मी. तोपर्यंत ते माझे व्हिडिओ आहेत ना बेसिकचे, ते थोडे हे कर, म्हणजे नाही का, स्लोली, म्हणजे इंजिनिअरिंगचे बेसिक्स पण कव्हर होत जातील.
ठीक
ओके.
आहे. ओके.
सर मॉडेलिंगला आपण स्पॅन कन्सिडर केला ना, तो क्लिअर स्पॅन घ्यायचा का नेहमी सेंटर
टू सेंटर? Whenever we model, okay, good question. Whenever we model for beams, okay, you ask the question again, go ahead. In detail, I will tell you. See, तुमचं हे झालंय का? E-tab झालं होतं का? नाही ना?
नाही सर, पहिला.
Okay. Those who knows the E-tabs, they know how to model that, but I will tell you. So if it is a column in plan, and let's say this is your beam in plan, Then again column in plan. These are your columns. And these are your beams. Let's say this beam is having width of 300 mm. And the columns are also 300 wide. But this column is having 600 dimension. Let's say this is having 400 dimensions. And width of column and beam are 300 only. Now, if you want to model this, then now you have to draw a center line which is passing through the beams first, okay, and columns also, but it should pass through the beam. Then it should pass through the again beam center. समझ में आ रहा है? Getting this? So this is my center line which is passing through the beam center. So the dimension from here to here is your dimension for modeling. That means I can say this is my this intersection. ये center line और ये center line का intersection is my first node. Then again second node is this, and here also it will be ये center line है. Then this is my nodes. Got this? कसं घ्यायचं dimensions?
Yes, sir.
So मी पहिल्यांदा beam चे centers draw केले असे like this. All beam centers, and मग त्याचा intersection is my point. Not the center of the column. Please keep in mind. Center of the columns नाही घ्यायचे. Getting? Center of beams, but the beam should rest on the column. इथं येणार तो point. समजते का?
Yes, sir.
And this will be my dimensions. And for height साठी कसं घेणार? height साठी is question आहे ना. Height ला floor to floor height घेऊन टाकायचं. That is a very easy way. So if this is your beam, these are your columns. Let's say these are your columns. Then yeah, there is a plain beam over here. Let's say bottom floors. So this will be my floor to floor height. Generally लेते हैं ना वही लेने का 3 meters. Let's say for example. So this is my floor level. It may be plinth or bottom floor level, and this is my first floor or upper floor levels, whatever. So this is the node is here and here. Here, please keep in mind at the top, not at the center of the beam, right? यहाँ top लिया तो यहाँ भी top लेने का. So this will be my column. This is my column. Any questions?
सर
Yes.
सर जैसे ई टैब्स और सर स्टैड प्रो में जो एनालिसिस और डिजाइन का उसमें मतलब सर डिफरेंस क्या मतलब इन दोनों में?
या आपका ई टैब हुआ है तो मैं थोड़ा सा बताता हूँ. सी ई टैब we can model the slabs in ETABS. That is the first advantage as a shell element. मतलब actual slab model कर सकते हैं stiffness. Staad we cannot model the slabs effectively. What I'm saying, we can model it, but it is very complicated, and rather I would say कि I don't use that modeling the slabs in the Staad Pro because there are other issues regarding that. I will tell you in the ahead. First thing is that. Second thing is Staad is a frame analysis model. Okay. So it is not so much advanced. It is a frame means the way we are doing manually. ऐसे एक frame रहेगा simply supported या 3D frame रहेगा. So we can have a 3D frame, and the way we do it manually, only it is doing with the softwares, this Staad, with calculations. Then results. Now, you know, you can see this. These results we have modeled where we have modeled at the center. Whatever I told you just now, that we are modeling this at the center. And let me do one thing. अभी बताता हूँ, इस पे बताता हूँ स्टैड में. Now, so these results, we can get these results at the center point, isn't it? This node is at the center. समझ में आ रहा है?
Yes, sir.
We have modeled it at the center, correct? Center of the column. ये line center of the column है ना हमारा. Actually,
Yes, sir.
हमारा real structure कैसे है? The real structure is like this. I will tell you. The real structure is, this is my width of the column. ऐसे है, मतलब ये मेरा width है ना. There is a width to the column. Whatever 300, 400 हमने कुछ लिया है, whatever. But we have modeled this line at the center of the column, correct? Then we have modeled the beam. ऐसे किया था ना. So this is my, ये 600 है ना कुछ तो depth, 700. ये depth of beam. But I have modeled this at the top, correct? And again there is a column over here, and there is a width to the column. So the real structure is like this, and I have modeled it for column at the center and beam at the top. Now you can see here. अभी ये थोड़ा सा. So this result, Staad results, you can see they are coming at the center point. Yes, ये मेरा moment जो है 23.2 कहाँ आ रहा है? यहाँ आ रहा है ना, ये point पे. Yes or no?
Yes, sir.
Now there is a added advantage in the ETABS. Reality में center पे आएगा क्या moment? बताओ. Can there be any bending moment at the center for beams?
No,
Center.
sir.
Why? क्योंकि ये column है ना यहाँ. Can you
Yes,
see
sir.
column is still here? So how can the beam bend within the column range? Column में कभी beam bend हो सकता है. Beam तो यहाँ से आगे bend होगा ना. That means our bending moment is important at this point. ये line पे, ये यहाँ से bending moment मेरा important है. That means this value is very important for me for design. This 23.2 is actually at the center, which is not real. Higher side पे आएगी. समझो you get this value as a 19.1, let's say. Now this 19.1, whatever value at the face of the column, you will get in the ETABS, which is a realistic. ये realistic है ना? Realistic and optimum. Yes or no?
Yes, sir.
So you get these results in ETABS, in bending moment diagram. जो दिखते हैं ना bending moment diagram, तो यहाँ result मिलते हैं हमें face पे. So you can have an optimized design, मतलब cost effective आता है, क्योंकि Staad cannot give these numbers. ये number center पे देता है, इसलिए always they are more. If you want to see the results from Staad, you can see it. I'm not saying that, but it is very difficult task. I will tell you sometimes in the next session. You just remind me this question. How to see this result in Staad. लेकिन ये Staad पे result देखना बहुत difficult है. It is always better ये refer करो. मतलब Staad में हम कभी भी ये results पे काम नहीं करते. It is very difficult to extract the results that way. Okay. लेकिन ETAB में already inbuilt facility automatic. That's why we can directly take these results from ETABS. So that is one advantage from ETABS. That's why I generally recommend for buildings the ETAB software. And Staad is very classical software which uses the frame modeling technique. I would say it is an extension of manual calculations. See, we are not trying to compare the Staad and ETABS in terms of advantages and disadvantages. क्योंकि हर एक सॉफ्टवेयर का अलग अलग खासियत है. बट इफ यू आस्क मी इन ETABS, मुझे जो पसंद है ये पसंद है कि इट गिव्स द रिजल्ट्स एट द फेस एंड दे आर वेरी ऑप्टिमम. इसलिए स्टील क्वांटिटी रिक्वायर्ड कम आता है बहुत बार. That is first point. And second point, I can model the slab in ETABS effectively. Stat में modeling slab is very difficult. Rather हम करते ही नहीं. So that is the advantage I generally have with respect to the मतलब stat के ETAB में ज्यादा advantages है वो. Then you will ask that stat कम है क्या? नहीं, stat में भी ये जो classical tool है ना, जिससे मुझे feel आता है कि ये सही है गलत है, क्योंकि मैन्युअली कैलकुलेशन करते समय मैं रिजल्ट कौन से निकालता हूं? यस, whenever I do manual calculation, which results I get? यही ना सेंटर पे.
यस सर.
क्योंकि सेंटर पे हम मॉडल करते हैं ना मैन्युअल कैलकुलेशन मॉडल भी. सो आई कैन गेट द कंपैरिजन ऑफ मैन्युअल कैलकुलेशंस. समझो मेरा मैन्युअल 22 आया है समझो, और स्टैट दे रहा है मुझे 23, तो आई कैन कंपेयर डायरेक्टली. अभी स्टैट में दिए, ईटैप में अगर मुझे 19.1 दिया ना, तो फिर कंपैरिजन थोड़ा दूर हो जाता है, मतलब दैट्स इट. So that's why for steel structures generally we use Staad Pro software, क्योंकि स्टील में सब सेंटर लाइन मॉडल ही रहते, फेस पे रिजल्ट्स लेते नहीं हम, थोड़ा हायर ही देते, because there are connections and so other things. So every software is important for different type of structures. So ये है advantage, and there are many other things, but है ये सबसे पहले ETAP से पहले हुआ ये, and it has been used in all over the world in the beginning. And it was a very intuitional software I generally see. It is more connected to me as a human being, because it is almost extension of manual calculations. इसलिए stat is important. Like it is as if harmonium, you know that harmonium is very classical. अगर harmonium का अगर if you learn harmonium, उसको मजा नहीं आएगा, isn't it? समझ में तो पियानो मतलब अच्छा म्यूजिक है उसका, नहीं क्या? दोनों में कॉर्ड्स एक ही है, उसमें सब सुर भी एक ही है, फिर भी हारमोनियम में मजा नहीं आता, क्योंकि वो बहुत मतलब बोरिंग और थोड़ा सा क्लासिकल है, और पियानो में थोड़ा सा मजा है, थोड़ा मॉडर्न है, और बाकी एक्चुअली टूल एक ही है. सिमिलरली स्टैट में भी वैसे मजा नहीं आता, लेकिन ईटैप में बहुत ज्यादा मजा है. समझ में आ रहा है? दैट इज द डिफरेंस. डिफरेंस ऐसे है उसका. बाकी क्लासिकल लेवल पे दोनों भी है सही, बट क्लासिकल में ज्यादा ये आता है. इट इज हारमोनियम, दैट इज पियानो, दैट्स इट. बट उसमें जो कुछ एडिशनल फैसिलिटीज है ना, दैट व्हाटएवर आई टोल्ड यू, दे आर, दैट्स व्हाई आई जनरली इंक्लाइन टू इट फॉर accessibility, एंड इवन अदर पीपल आल्सो, मतलब मैं मतलब इन जनरल सब कंसल्टेंट्स. ओके.
Okay, sir.
So you practice this. I'm not taking too much today. Slowly we will learn additional, but please do the practice. Actually कल भी ये होने वाला है हमारा, and then we will have 2 days break, and then we will continue. Okay, so you can practice in between.
Okay, sir.
Practice as it is what I told you. Just don't go, don't get distracted to other commands and tools. Okay, please. So thank you all.
Thank you, sir.
Questions है क्या? हाँ
हॅलो सर,
हाँ हाँ.
जुने रेकॉर्डेड व्हिडिओ सर कॉन्टॅक्ट करू तुम्हाला करू की स्टाफ मध्ये कोणाला करू?
प्रज्ञा मॅडम आहे ना त्यांना.
हां हां चालेल. ओके, थँक्यू.
ग्रुपवर मेसेज टाकला तरी चालेल. प्लीज ऍड टू द बेसिक क्लासरूम सेशन.
ओके ओके, थँक्यू.
गुड नाइट सर.
गुड नाइट. थैंक यू.
Thank you,
Good
sir.
night,
Good night,
sir.
sir.
Good night.
Thank you, sir, and good night.
Good night, sir.